Hello everyone. Today we're going to be looking at temperature, and to study this we're using a PhET simulation where we have basically just a can with a substance in it. In this case we have neon gas. So we have all these little bitty atoms floating around in here, and while these are neon atoms, I'm going to refer to them as particles from here on out, because we'll look at some substances that will not be just atoms. There'll be multiple atoms stuck together, but we still want to think of them as just one chunk of something. So we'll call them particles. So we've got these neon particles whizzing around inside this canister, and we want to know what temperature means in this case. Temperature is a measure of the average kinetic energy of a substance. And when I say that, kinetic energy may sound a little bit intimidating. You might remember that from previous studies, but kinetic energy depends on two things: the size of the particles and how fast they're going. So the bigger the particles are, the more kinetic energy they're going to have, and the higher the temperature. The faster they're moving, also, the more kinetic energy they'll have, and the higher the temperature. So looking at this, we now know there are two ways to increase the temperature. We can increase the mass of the particles, or we can increase their speed. But you guys, I hope by now know that we can't just beef up those atoms. We can't make them bigger. We're stuck with the same size. So the only way to change the temperature of this neon gas is to increase or decrease the speed. And let's look at doing that. So I'm going to add some heat, and what this does is this increases the average kinetic energy of the particles of this neon gas. And so what you'll see is as I keep adding heat, they'll move faster and faster and faster. Also notice that it's important that we talk about the average speed, because if you watch real closely, some of them are moving slow, some of them are moving fast. And rather than try and talk about all those different speeds at the same time, we just use the average speed. Now, another way to look at this, and this is kind of tricky, so bear with me, make sure you understand what's going on here. I'm going to change the substance now from neon to argon. Argon atoms are much bigger than neon atoms. Now for this simulation, all the particles will keep their same speed. I'm just changing the size. So think about what that means. If mass goes up, kinetic energy goes up, and the temperature should go up, even if they stay at the same speed. So I'm going to change that to argon atoms now, and notice how the temperature jumped. Temperature is right up here, in case you're wondering where I'm seeing that. For the neon, the temperature is 55 Kelvin, and if I change this to argon, without changing the speed of any of the particles, it jumps up to 189 Kelvin. If I change this to water, which is much, much larger even than argon, the temperature goes up by a lot, 809 Kelvin. So again, when this comes down to it, for temperature is the average kinetic energy of the particles in a substance, and it depends on two things: the mass of the substance and its speed. But since we can't change the mass of atoms, remember they're stuck, they're a certain size, you can't make them bigger, then the only way to change the temperature of a substance is to change the average speed of its particles. As they move faster, the object gets hotter. As they're cooler, the particles are going to move more slowly.